Everybody, this is Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Next, the classification of liquid crystal. We may classify the liquid crystal into several types. This is one kind of classification. The liquid crystal can be classified into thermotropic liquid crystal or lyotropic liquid crystal. And in the thermotropic liquid crystal, it is further classified into high molecular mass, that is polymers usually having higher molecular mass. Why? It is the combination of several monomers, so they are usually having high molar mass. And there is another type of the thermotropic liquid crystal can be another type of materials, that is a low molar mass. Okay, here the high molar mass can be classified into side chain, main chain, since they are long in size. And in the case of low molar mass, we have rod like shape and disc like shape. Okay, we have these two types of materials also. And the rod like shaped material is classified into nematic and smectic. These are the main two types of liquid crystal. The nematic may be classified into further ordinary nematic or twisted nematic. The twisted nematics are usually having cholesteric, which are having some important applications in scientific field. The smectic materials are perpendicular in arrangement and tilted angle long axis also available. The disc-like shape are further classified into discotic nematic, nematic columnar, intercolumnar order, high order columnar. Likewise, we have the classification in disc-like shape. And the high order column can be further divided into discotic columnar and discotic column nematic and smectic like arrangement. So, what are smectic and nematic? Now only we are going to learn the meaning for the word. Smectic means soap-like. It is a Greek word. Smectic is derived from a Greek word. In its meaning is soap-like. Okay, it spread because it spreads over on a clean glass surface, and they are forming series of terraces and strata. When we pour water, it just spreads like anything. But the smectic liquid crystal, if we pour, they are spreading in layer by layer. That is called terraces or strata. This is the nature of smectic materials, so they are called soap-like. And following are the examples of smectic liquid crystal: ethyl para-oxoxybenzoate, ethyl para-oxoxycinnamate, N-octyl para-oxoxycinnamate. These are all the materials which are showing smectic nature. All of them's transition temperature and melting temperature are tabulated here. The ethyl para-oxoxybenzoate having 114 degrees Celsius as a transition point and 121 as its melting temperature. Okay. Likewise, all the other materials are having different transition points and melting temperatures. Now, what is nematic? Nematic means thread-like in Greek, thread-like material, because the nematic materials are having their property as thread-like, and their flow is Newtonian. This is just like water, but their flow is Newtonian. Their viscosity is low compared to liquids. They are not behaving as normal liquids. Their viscosity is very low. Okay, so they will behave differently with Newtonian moment. The following are the nematic type of liquid crystal: para-oxyanisole, para-oxyphenol, para-methoxycinnamic acid, anisaldazine, dibenzyl benzidine. These are the material which are showing nematic like liquid crystal. and the values are tabulated here. The transition points and melting points are here. Okay, you can have the details here. There is one material, there are some of the materials, and I am giving you one material which is showing both the nature of smectic and nematic property. Ethyl anisal para-aminocinnamate. This material of liquid crystal shows both smectic nature and nematic nature. They will be having this type of materials are showing both smectic and nematic nature. And there is one more type what we have seen already in the classification. It is cholesteric material, and these are the PBLG and PBDG are the examples for cholesteric liquid crystal. That is, what is PBLG? It is polygamma benzyl L-glutamate. Polygamma benzyl L-glutamate, that is given shortly known as PBLG, and PBDG is polygamma benzyl D-glutamate. This is another thing which is cholesteric liquid crystals. And these are the different types of phases: smectic, nematic and cholesteric liquid crystal phases. Cholesteric liquid phases, optically active compounds, show many characteristics of nematic behavior that should be considered and noted. Cholesteric liquid crystals are different liquid crystals, but they are showing nematic behavior. These are the nematic structural arrangements. Here every material are symmetry like arrangement, uniformly equal distance, just like smectic phase. In this case, some materials are some pieces of material or atoms, they are arranged in between, so they are having nematic nature, nematic phase. And these are all cholesteric material, which some materials we already discussed, that is nematic. They are showing nematic phases. And opacity property, that is optical nature property, is increasing when we go from nematic to cholesteric. That is shown in this diagram, that is in this curve, which increasing the opaque nature, that is optical nature of the liquid crystal material. Polymeric, next polymeric liquid crystals, which are usually prepared from monomers. Here LC monomers, when we pass the photo radiation, they are becoming LC network, that is the liquid polymeric material is formed. Films are freestanding coatings, they are used in films, freestanding coatings on glass or plastics, additives to non-reactive LCs, pigments, device integrated sensors. In all those materials, these polymeric materials are used. There is LC diacrylate material. This is one of the polymeric liquid crystal which is used widely, and its lithographic patterned structures are given here. These are the chiral nematic. This is played nematic. This is twisted nematic. This one is a smectic, and this one is tilted nematic. This is the polymeric liquid crystal behavior, application and preparation of polymeric liquid crystals. And now we are moving into the applications of liquid crystals. Display application of liquid crystal, we may be knowing before the LED type of televisions and other materials, we used LCDs, liquid crystal displays, that is given here. And in many materials, like in many equipments, like the thermometers and some kind of calculators and some kind of coulometric materials, calorimetric materials, potentiometry, they are used. The liquid crystal displays are used. The thermal mapping and in thermal mapping and non-destructive testings, the liquid crystals are used. And cholesteric liquid crystals or mixtures have also been suggested for measuring body skin temperature. And in the medicinal use we can have that. And to study the tumors, about the tumors, the liquid crystals are used. And in optical imaging, and the liquid crystal materials are used with the nanostructure. So in chromatography also liquid crystals are used, and some liquid crystals are used as solvents in spectroscopy. That is a very important application. And this is one of the display which is shown by a cholesteric liquid crystal material. So when the temperature is low, it will shows cool, that is blue in color, and when it increases, it transforms to green, yellow, orange, and red. So due to their optical activity property, the cholesteric liquid crystal are used in many color display sensors. So some kind of color display sensors, when it is warm, it shows a different color. When it is hot, it shows a different color. When it is cold, it shows blue color. So red to blue is the color change usually they are possessing. So that possession of that property is used in the materials, sensor materials. And this is liquid crystalline polymer material. We have different material, the main chain polymer, side chain polymer, partially cross-linked polymer, network polymer. So different materials are having different kinds of applications. High strength elastomeric materials can be prepared by using this kind of liquid crystals. Biofunctional materials also, in biofunctional materials also the liquid crystals are used. Electrofunctional materials also they are used. Photofunctional materials also they are used. And separation, that is solvent like materials, they are used. So a wide variety of applications are shown by liquid crystals. That's all for now from the liquid crystal topic. Thank you.